Alright, so it looks like I'm recording now. So let me go ahead and do this. It says experimental and theoretical probability. Click and drag these words to where they belong. So experimental probability is what does happen. So when we take a look at the two types of probability, experimental probability is what does happen when during an experiment. So we drag this box. I accidentally clicked. Come on. There we go. Now, theoretical probability is what should happen in an experiment. So we're going to take a look at that. As the number of trials in an experiment increases, the experimental probability is going to get closer to the theoretical probability. So what's the probability that the spinner will land on red? Well, one thing that we have to do is we have to count up the number of slots or wedges on the spinner. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of them are red. So in each of these answers, we're going to wind up being over 10. And so if we look here, there's 3 reds, so the theoretical probability is 3 out of 10. Over here, we can see that there's 2 blues. So this is 2 out of 10, or that's 1/5. Down here, in the yellows, we have 1, 2, 3, 4 out of 10, or that is 2/5. And then what's the probability that the spinner will land in orange? Well, there's only one spot that's orange, so that's 1 out of 10. Now, that's theoretical. So experimental, what happens is they spin the spinner, and we're going to have to count up and add the number of times that they spun the spinner in order to find out our experimental probability. So there's the difference. So 5 plus 6 is 11, plus 3 is 14, plus 10 is 24. So all of these answers are going to be over 24. So let's look. It says, what's the probability the spinner landed, not will land, but landed on the color red? Well, landed on the color red, that's 5 out of 24. Over here, we've got, what's the probability that the spinner landed on blue? Well, that's 6 out of 24. Now, 6 out of 24 is also known as 1/4. So, what's the probability that the spinner landed on yellow? Well, we've got 10 out of 24. Now, that can simplify, though, down to 5 out of 12. And then this last one here, orange was 3 out of 24. Which can simplify to 1/8. So as we go to our next experiment, we're going to look and think about what's going on with experimental and theoretical probability once again. Experimental probability is what actually occurred. Theoretical probability is what you think will occur. So again, experimental is certainty, theoretical is like what we possible. So just trying to think about different ways of saying the same thing over and over again. So as the number of trials increases, the experimental probability gets closer to the theoretical probability. It's the same question as before. We just want to hit home that idea. So we look. There are 6 sides to a die. One of them is a 1, so we're looking at 1/6. There's 6 sides to a die still, and so there's 1, 2 on the die, so it's 1/6. Right here, same thing. There's 1 out of 6. And here there's 1 out of 6. So what's the probability that the die will land on an even number? Well, now there's 3 even numbers, and so that puts you at 1/2. Over here, what's the probability that the die will land on an odd number? Well, if we look there, that's 3 out of 6 again, but that's 1/2. Now, that's all in theory. In practicality, in experimental, what happened in the experiment was this. And so, we look here, what's the probability the die landed on? Well, hold on a moment. It's landed, so we've got to add up this column right here again. So 3 plus 8 is 11, plus 2 more is 13, plus 5 more is 18, plus 8 is 26, plus 10 is 36. So this is going to be over 36. So landed on a 1. We read in the column, it says 3, so 3 out of 36, which means that we're looking at 1/12. Over here, we've got 2, so that's 8 out of 36, which simplifies down to 2/9. Right here, we've got 3, so that's 2. 2 times it landed on a 3 out of the 36 rolls, so that's 1/18. Over here, we've got landed on a 4. Landed on a 4 is 5 out of 36. Landed on an even number. Now, we're going to have to do some adding, but before I do that, I'm going to remember it's out of 36. So, we've got a 2. When 2 is rolled, that's an 8. Well, there's 8 rolls of 2. There's 5 rolls of 4, so that's 13 even rolls. And then there's 10 more, so that's 23. So there's 23 even rolls. That means that the rest of them, because these are complementary events, 36 minus 23 is 13. Now, if you don't see that and don't understand complementary, I'm going to go back and explain this. There's 3 1s, which isn't, and 1 is an odd number. There's 2 3s, which is an odd number, and there's 8 5s, which is, and 5 is an odd number. So we have 3 plus 2, which is 5, plus 8, which is 13. Now, if you look at that and compare that to this slide back here, we were expecting 1/2 of the time for it to land an even, 1/2 of the time for it to land an odd. But experimentally, that's not what happened. All right, so theoretical probability is prediction. Experimental probability is results. As the number of trials in an experiment increases, experimental probability gets closer to theoretical probability. We're just trying to beat that into your heads. Hopefully we do. All right. So, oops, I meant to go there. All right. So we've got these marbles in this jar. Probability of choosing red. Well, we got to count them up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's 20. So all these answers will be out of 20. Oops. Now, with them all being out of 20, we've got red. So 1, 2, 3, 4, 5, 6, 7. I count 7 out of 20. Probability of choosing green. So we look 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I count 10 greens. So the probability of choosing blue is the rest of them. And we've counted 17 of them, so there's only going to be 3 blues. Now, you don't have to do it the way that I just explained. You could just come over here and count all 3 blues if you wanted. I just like using complements when I can. So here we go. Now, we're going to find out when it landed. So this is the experimental probability side. So we got to make sure we understand something. We got to add these together. 7 plus 8 is 15, plus 6 more is 21. So we're looking at 21. And red in the table is 8. So that's 8 out of 21 times it landed on the color red. Then out of the 21 times, green was landed on 7 times, which means that's a third of the times. Whereas I didn't do this in the last time. We expected, by theoretical probability, we expected it to land on it half the time, and instead it landed on it a third of the time. Okay. So what's the probability that the spinner will land on the color blue? Well, this is going to be 6 out of 21, which simplifies down to 2 out of 7. All right. Theoretical probability. Theoretical probability is, if we look at this, I'm looking at my options here. We got the number of times desired outcome occurred. That is going to be an experimental probability. whereas the number of trials in an experiment would be part of experimental probability. And then if you look here, this is possible. Possible comes down to theoretical probability. Number of possible favorable outcomes, and the total number of possible outcomes. So, here we go. As the number of trials of the experiment increases, yes, the experimental probability gets closer to the theoretical probability. Okay, now when you flip a coin, the probability it lands on heads is half the time. And when you flip a coin, the probability it lands on tails is half the time. It's theoretical, but we have an experiment. And we run the experiment 15 times, because 6 plus 9 is 15. And out of this, 6 of the 15 times, it landed on heads. 6 out of 15, that simplifies down to 2/5. Oops. And then the probability it lands on tails, well, that's the complement. So you could just run straight to 3/5, but I will actually do the 9 out of 15 because that's from the table, and then that simplifies to 3/5. Now, we're onto the slide that a lot of people, I think here's the problem. We choose to not read. Dean spun the spinners below, read it repeatedly, and kept track of his results in the frequency table shown. Use the spinners and tables to answer each question as a simplified fraction. When you get your answer, find it in the answer choices at the bottom of the slide and drag it to the correct place. Not all answers will be used. So landing on blue in the first spinner. There's 3 spots that are blue, and 1, 2, 3, 4, 5, 6, 7, 8. 8 total slots. So that's 3/8. Landing on a green. Landing on green in spinner 1, that's 1, 2, 3, 4, 5. There's 5 spots there out of 8, so 5/8. That's this guy right here. Landing on a blue in spinner 2. Well, there's 2 spots, and there's 6 slots in total. 2/6 simplifies down to 1/3. Landing on either a green or a purple, that's 1, 2, 3. 3 out of 6, which is 1/2. Landing on a yellow, that's 1 out of 6. Not landing on green. Not landing on green would be everything but not green, so that's 1, 2, 3, 4. 4 out of 6, though, is 2/3. Okay, now we've got to do experimental probability. So that's where we look at this little table below. We see that there were 20 spins. And so out of those 20 spins, 5 of them were blue. 5 out of 20, though, is 1/4. So, in the next one, sorry, I'm looking to see what, okay, it's not going to tell me. Oh, well, let's see, landing on a green, so we got 15 out of 20, and so 15 out of 20, that simplifies down to 3/4. Now, we go to the next table here. 20 plus 15 is 35, and 6 plus 9 is 15 as well. So let me do it this way. 15 plus 15 is 30, plus 20 is 50. So we're going to go out of 50, but this is 20 out of 50, and that simplifies to 2/5. Landing on either green or purple. Green is 15, purple is 9, that's 24. But it's 24 out of 50, so you're going to have to divide both those by 2. 24 divided by 2 is 12. 50 divided by 2 is 25, so we're looking at 12/25. Landing on a yellow, that's 6 out of 50. 6 out of 50, you're going to divide by 2, so that's 3/25. And then not landing on green. So if I take 15 here, that's the number of greens. The complement of 15. 50 minus 15 gives us 35. And so 35 over 50. 35 divided by 5 is 7. 50 divided by 5 is 10. So that's 7/10. Now, if you spun the spinner 400 times, about how many times would you expect to land on green? So this is where we do a little side math. And I'm going to show this right here. want to show you my work. Alright, I'm going to go there. So 400 times I spin the spinner. And how many times would you expect it? Expect means theoretical. So you'd expect it to land on green 5/8 of the time. So you're going to go 400 times 5/8. Well, 400 times 5/8, take 400, divide it by 8, that gives you 50. Then times 5, that would give you 250 times. You'd expect it to land on green 250 times. Now, if we spun the spin, so I'm going to do this again here. So let me go into this little box here. There we go. Great. This next one, you spin it 300 times. And how many times would you expect? Again, theoretical probability. So you expect it to land on blue in spinner 2. So we look at that, it says 1/3. So we're going to go 1/3. And that equals, so 300 divided by 3 is 100, times 1 is still 100. So we're going to expect it to land on blue 100 times. Now, this last one is an interesting question. I'm going to give myself some room here to keep working and showing my work down here. I'll make myself a new text box. That wasn't really what I was expecting. Let me see if I can... There we go. Much better. Okay, we're going to do 2 theoretical ideas. Because experimentally it lands on it 65 times. It lands on green. So what we're going to do is we're going to take 100 spins. And in spinner 1, it should be 5/8. So 100 times 5/8 is 62.5. Whereas in the spinner 2, it lands on green. Well, I have to think about this. That's 2 times. The blue spinner also does 2 times. So the blue and the green, the theoretical probability is actually the same. So landing on blue is 1/3, so landing on green is 1/3. And that would be 33.3 times. So if I look between 62.5 and 33.3, spinner 1 is closer to 65 times. So I'm going to guess that we're working with spinner number 1. There you go. So now I finished this up for you. Hopefully you can take care of this and get this done yourselves.